Hello everyone and welcome back to CodingBulls. Today we will continue our competitive programming series and we will take a look into the first three problems of my code versus contest that I created. In order to create a code versus contest, you need to click on Propose a Contest Problems. This is only available for you if you have a certain rating and number of contests that you participated in it. If you have higher rating, you need lower number of contests, but if you are lower rated, you need more contests. If you made this criteria, then you can click on this and come up with your own problems. In order to create a contest, you need at least 5, usually 6 problems that you create, and then if they are accepted, they are reviewed and accepted, then you can create a problem. In this video, we will take a look into my contest and the first 3 problems. You can see at the problem setting that my contests are here, and then you can go ahead and open any of the problems. Enter the contest. As you can see, there is a different page right now than if you just enter a regular contest. The reason for this is because I created the contest. I'm not a participant here, but a contest manager, which has different privileges. So let's take a look at the first 3 problems. And by the way, you can see that if you go back to the problem, after every contest there is an option of virtual participation, meaning that you can participate in the contest after it's over and you can see what your results would have been if you were to participate in that normally. This is a great way to practice, and if you want you can go ahead and participate on my contest virtually as well, and you can pick any other contest to do this. If you are curious about the problems, then it's time to take a look at them. So the first problem that I created is an importer named important exam, and there is a test and there are 5 possible answers, and in each of them we remember what the test takers choose the options, and for each problem there is a certain points that you get if your answer is correct, and we want to output the maximum possible total score of the class if we know each of those who and what answer they give, but we don't know the actual answer to the problem. So when I created this problem, the story behind this is in high school I went to school which had a really good mathematics education, and there was a national contest, mathematical contest, where you had 30 problems, and in each of them you had to pick between 5 options, and when you pick you have that answer and you get 5 points for each correct answer and 1 point if you don't answer, so you basically lose 1 point for incorrect answers. And for each of these problems, after the contest ended, with my classmates we usually discussed the problems, and we didn't actually know the answer, the official answer, but we knew what we each picked. And because we discussed these problems, we could figure out what the actual answer is, and we basically made the answer sheet without having the answer sheet before. So after the contest ended, we just discussed it and saw how everyone did. And usually what happened is the majority of the picks were correct. So if out of 10 people 9 picked the same thing, then it's probably the right answer. And the solution in this problem as well is really simple to see. We need the answer on each question to be the one that most people pick, because that will be the highest possible score. So we go ahead and copy this case and show you the solution. So what we need to do is first we will take the input, which is the strings for each of the students who took the test, and we have their answer, and then we will take the weights. Now for every question independently, so we will look through the questions, we will have the maximum number of people who choose the same option, and we will store how many people picked in a certain question a certain answer. So we will use this formula that you can subtract two characters from each other. So we have this is a string, and the string's character is referred here. So this is a character, and from a character you can subtract another character, and then you will get an integer. So capital B minus capital A will be 1. Capital A minus capital A will be 0. So this is a cool shortcut that you can do, but this only works if they have the same case, because if you subtract a capital B from a lowercase a, then you will get a seemingly random result. The reason for this is every character has its unique code, the ASCII code, and the ASCII code is really good because it's an alphabetic order for the characters. But if you have lowercase and uppercase, then you have to come back to the same case. So make sure to have the same here. And this is a cool shortcut because we know that the input contains characters from capital A to capital E. So this will be from 0 to 4, which is inside our array limit. So we will increase the value of that, and how many people picked that answer. And now for all of the possible picks from 0 to 5, because there are 5 different options, we store the maximum value. And then we will increase the answer by the number of people, the maximum number of people who pick the same answer, multiplied by the weight of the problem, the points that you get. And then when we add it up, we simply output it. So if we go ahead and run it, I already built it, so I just press run. And we can see that it's a correct answer. By the way, obviously, because I created this contest, I have already uploaded all of the results way back in 2019, so I will skip the uploading part. I will just show the solutions in CodingBulls. So this is a simple format question, and you can solve this. Now let's go to the problem B. So we are given an array, and in one operation we can choose two elements and decrease each of them by 1. And we need to check if it's possible to make all of the elements equal to 0. Therefore the name making a 0 array. And we have the integer the size of the array, and we have the array. So this will be a greedy solution. And the answer for this problem is, it's simply, obviously the first thing that you want to see is because we decrease two elements by 1 at each operation, the sum of the elements must be even. If it's odd, it will always be odd, so it's not possible. So this is the first condition. We go ahead, and this S here is the sum. We increase the sum, and if it's odd, then the answer is no. Otherwise, the answer will be yes, but there is one more condition, and that is the largest element cannot be more than the double of the largest element can't be more than the sum. The reason for this is if the largest element is the double of the largest elements is more than the sum, then even though if every single time you choose that element to decrease, and you need to choose another element to decrease as well. So we have the sum here, and the double is larger than this, so the rest, the sum of the rest of the elements will be less than the largest element. Meaning that even though if we choose that largest element every single time, we won't be able to make it 0 before all the elements reach 0. Because you obviously can't choose something to decrease if it's already 0, because then it won't be 0 anymore. So this is the other condition, and in every other case it's possible to make it. Simply by a really greedy solution, you always just choose the two largest elements to decrease, and the sum will be always even, so you will go through the solution, and this condition will always also be true because you choose the largest elements to decrease. So this is simply the solution. You can go and see if it works. You can just copy one of these. And I forgot to press build. So if you haven't built it, and if you press run, the last file that you built will be run. So in this case, this file is run, which is obviously not a problem. So you need to actually build it run, and we can see the answer is no. So you can see in these problems there aren't more test cases inside of a test case. Because I made this contest in 2019, and back then it wasn't a really regular thing to have multiple test cases inside the test case. This is a pretty new invention from CodingBulls. I would say maybe 1 or 2 years ago they started making this. So in these other problems, you most of the times don't have multiple test cases. And let's go ahead and check problem C. And this one, we are also given an array of n integers, and where n is odd, so we have an odd number. And the input, you can see that we have the n, we have a k number, and we have the array. And then we can make the following operations: choose one of the elements and increase it by 1. So, and we want to make the median of the array the largest possible using at most k operations. So you have the number k, and that's how much you can increase the numbers. You can divide it any way you want. You just want the median to be the highest possible. And we need to output the largest median. So the median, and that's why n is odd, because it's different. The median is different if the size is odd and if it's even. So if it's even, then it's kind of complicated, and if it's odd, it's really simple. So the median will be simply the middle element if you sort the array in order. So this array 1, 2, 3, 5, 5, you sort it, it will be 1, 2, 3, 5, 5, and then you take the element in the middle, which will be the 3. If it's even the size, then there are 2 ways to take the median. One of them say that the 2 middle elements will both be the median, so you have 2 medians. The other say that the average of the 2 middle elements will be the median. So I wanted to avoid this confusion, and that's why I created this problem where n is always odd, so it's more simple that way. So this will be a binary search, and what we will do is take the input, sort the elements, and again, as in a good approach and a binary problem, because all of the elements between 1 and 10 to the power of 9, and you can add at most 10 to the power of 9. So the largest possible number that you can get as a median will be to the 2 times to the 10 to the power of 9. The reason for this is that's the highest element you can get, because the highest starting element is 10 to the power of 9, and even if you use all of your operations on one single element, then you have 10 to the power of 9 operations maximum, which will be 2 times 10 to the power of 9. Meaning that's the maximum possible that you can get, even if you use everything there. And the minimum obviously 1, because every element starts with 1. So we have a lowest element that you can get and the highest element that you can get. And now we want to find the good element, so we will go to binary search. So we will go until small is not equal to big, and then we will just output either of them because they will be equal. And we will take the middle, which will be small plus big plus 1. Remember, if this plus 1 depends on the problem and depends what you do after it. So we will check the middle. This check function will see if the median can be at least this middle element. So we will check if the median is possible to be that. If it is, then we will set the small to mid because we can do it. And if so, that's the smallest possible answer that we can get, because we don't know if we can do higher, but we know that we can do this. But if we can do this, then the big will be the middle minus 1. Because we can't do this, so the answer can be this middle or higher. So this is the big. And as you can see, we will end up getting the answer. The only thing we need is this check function. So this check function will, what it will do is count how many operations you need to get the median to be that. So we sorted the array, and in order to the median for be a certain number, this x, you need the elements from the middle and over to be at least that much. So what you do is go from the middle element until the end and see how many moves operations you need to make it at least that much. So if this x is larger than the value that you already have, so x minus I is greater than 0, then you will increase the moves by the difference. So you need that many moves. And if it's already larger than k, then we will return false because we don't care anymore. And here we will return true if moves is less or equal than k, as we will return false. Alternatively, I wrote this code a long time ago, we can simply return this expression. So it's more simple this way. So this is simply the solution. Let's say we will take this input. So we will go and run it, and then we can see that the answer is 5. Going back to the problems, you can see that there are 2 more problems. Some of them have 2 subtracts. And I like these 2 problems, especially this nightmare. This is one of my favorite problems, and I worked a lot in this problem. And if you are interested, make sure to like and subscribe. And in the next video, we can take a look on the problem D and problem E of my contest. And also, if you would like to see how a contest is made in CodingBulls, let me know. Right? Drop a comment, or a like, or subscribe, so I know that you will be interested in a video. I will go through the basics now. So you press the propose contest, you will create your problems, it will be reviewed. Once they are accepted, you need to go ahead and check polygon.codebulls.com. This is the website which we use to create the problems, and here you need to create the statements, the tutorial for it. You need to create the test cases, you need to create the validators and the checkers. So the validator will validate if an input is correct. So if it has the good format, this is mainly for your test cases and hacking in the contest. And the checker will check if the solution is correct. So if it's just a yes or no or a number, it's really simple. You need to see if they are equal. Otherwise, there are some problems where there can be multiple correct answers. So you need to check the contestant's answer by a program, of course, if it's correct. And also, you need an iterator for interactive problems, which will run with the solution. And that's why this problem took more time, because it's an interactive problem. So, if you enjoyed today's video, make sure to like and subscribe. See you in the next video.